So today we're going to talk about permutations and combinations. Okay, permutation is where order matters. Order matters. Okay, permutation is where order matters. Okay, so let's real quickly take three letters: A, B, C, and D. Okay, and I want to arrange these four letters in different orders, okay? So, and it doesn't have to be A, B, C, and D. That could be one choice, but I can put either A, B, C, or D here, right? I could. So, if I want to fill in the first one, I have four choices, don't I? So, let's say I choose B. Once B is chosen, then I only have 1, 2, 3 choices for this one, right? Do you guys agree with that? So then let's choose C. After I choose C, I really only have 1, 2 choices to go here. Let's say it's D. And once I choose D, then I only have one choice, and that's just to put A there. Does that make sense? Well, let's see what I had. How many total? That's just one. How many total? Well, really, I would have had a total of 4 choices for the very first one because I could look at all 4 of them, right? Once I pick a letter, then there's only 3 left to choose from, times 3, right? Once I choose a letter, then there's only 2 left, one or the other, so then there's 2 choices. And then once I make that last choice, there's only 1 choice left, okay? This is a factorial. This is 4 factorial. 4 factorial is simply 4 times 3 times 2 times 1, right? 12, 24. So 4 factorial should equal 24, okay? Now, combinations are different. Combinations are like our coins where order does not matter, okay? So if order doesn't matter, then there's several things that can be counted as the same. Example, we flipped our coin, okay? Example, we flipped, say, 3 coins. Okay, here's our example of a combination. If I flipped a heads, heads, tails, or if I flipped a tails, heads, tails, or if I flipped a, oops, I wanted to make that a head, sorry, my bad. If I wanted to flip a head, heads, tails, tails, heads, heads, or if I wanted to flip a heads, tails, heads, those are all the same, right? You agree those are all the same? So the order does not matter. So you do a combination, order does not matter. Now there's formulas, okay? How do we find the formulas? So if we want to do a permutation, okay? If you want to do a permutation, you get this little symbol here, n, where n is the total. N is the total. That's it, total. Okay? And R is the number chosen. Okay, so look how this works. You guys with me? Here they have an example. We go 4P2, which is like saying, I have 4 people, and I'm going to pick a president and a vice president. Okay, I have 4 people, and I need to pick a president, vice president. So the order is important, right? If it's a permutation, the order is important. So this is like order is important. So let's say I want to out of 4 people. I want a president, and I want a vice president. Okay, so order is important because if I choose K to be the president and then pick Ben to be the vice president, that could be, but then if I chose the other way around, Ben to be the president and K to be that's a different combination, right? So the formula says, take this. So we go 4P2, right? Is equal to n factorial, which is 4 factorial over 4 minus 2 factorial. Okay, this is what the formula says to do, okay? My total group and how many things I'm going to put in order. My total group, which is 4, I'm picking that group right over there. And out of that group, I want to pick a present, vice president, so the order is important. So how does it work? Okay, that tells us n factorial, which is the 4 factorial, over n minus 2 factorial, which is going to be a 4 times 3 times 2 times 1, because that's my factorial, right? This becomes a 2 factorial, which is 2 times 1, which gives me a total of 12 things, okay? Total of 12 things. 12 ways to pick. Within this group, Price, there are 12 ways to pick in your group, 12 ways to pick a president and vice president. All 4 of you, there's 12 ways to pick a president and vice president, okay? Now, combinations are different, right? Combinations are different because some things are the same, okay? So with combinations, order does not matter, okay? So to do a combination, here's our formula. The reason it's divided by r factorial is because there would be less. The reason it's going to be divided by r factorial is because there's going to be less choices because some repeat, right? So our heads, heads, tails, our heads, tails, heads, and our tails, heads, heads is really just one combination, right? There's 3 ways to look at it, but all 3 of those ways would be the same, right? Okay, now, if I wanted to instead, say in this group, my Price and Ben group, I wanted to pick a committee of 2. Now the difference is committee of 2. So if I pick Ben and Price to be on my committee, or if I pick Price and Ben, it's the same committee. Does that make sense? I wouldn't count it twice. I count that once. So there should be less choices, right? You guys agree with that? Should be less choices. So let's see what the formula says. The formula says you take, so you're going to go 4, because that's the total of my group. There's a combination of 2. So it says you take 4 factorial over 4 minus 2 factorial times 2 factorial. See the formula? And then we went, so I go 4c2 is equal to 4 factorial. Okay, I'm following the rule, over 4 minus 2 factorial times 2 factorial. Okay, I'm just following the formula. Yep, which should be 4 factorial is 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 over 2 factorial times 2 factorial, right? So I'm just following the formula, which should be 4 times 3 times 2 times 1 over 2 times 1 times another 2 times 1. Okay? I'll get 24 over 4, which is 6. Okay? Now we got 12 last time. Because 12 last time, we had to be specific. Order was important. We need a president, vice president. So there should be more choices because president, vice president, then president, vice president is a different order. There's more of them, right? But if I say a committee of 2, I got a committee of 2. Oh, I got a committee of 2. Same one we would count twice, right? So there should be less under combinations, okay? Now, turn the page. Okay? Let's look at number 3, okay? So your rock band has 9 songs recorded, but you can only want 5 put on your demo CD, okay? You watching? Okay? First of all, are the songs different? Yeah, they're different, aren't they? So the order would be different, wouldn't it? I mean, if I wanted to put my first song and my second song, I'm not saying songs, they're different songs, right? So the order is important on this one. This one's got to be a permutation. See the difference?
Is it just 5 factorial?
It's going to be, a permutation, so it's going to be 5, it's going to be,
Can we move it this side?
yeah, there are 9, so it's going to be a 9, it's going to be a 9, P, 9P, 5, okay? Now, we're going to have to use our formula, right? 9P5. Order is important because I got the first track is like my rock song. The second track is like maybe my mellow song, right? But if I reverse that, that would be a different CD. You guys agree with that? So order is important. So I'm going to go, okay, let's see my formula. If I go back, my formula's got to be my n factorial over my n minus r factorial. That's my formula from before. So I'm going to have a 9 factorial over a 9 minus 5 factorial. Okay? How am I doing? Am I going too fast? Or am I okay? So 9 factorial is the same thing as 9 times 8 times 7 times 6 times 5 times 4 times 3. Oops, I'm running out of room. I'll have to do it down here. 9 times 8, 7, 6, 5, 4, 3, 2, 1 over 4 factorial, which is 4 times 3 times 2 times 1, right? You with me? All of these can cancel with all of those, right? And then I need a calculator to figure out the rest. Clear, 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 clear. So I go 9 times 8 times 7 times 6 times 5, and I get an answer of 15,120 different ways you can cut this CD. Isn't that crazy? 15,000 different ways that you can make your CD. You got 9 songs to choose from. That's a lot, isn't it?
Why don't you buy 2 demo CDs?
Right? Now, let's look at 5. Let's look at 5. Am I going too fast? Okay. Actually, I want a combination. That doesn't give me a combination. All right. Okay, 7.
When will we use this in real life?
Oh, my son, who works for Amazon and makes over $200,000 a year, uses this all the time. Yeah, probabilities all the time. Okay, so just saying. You asked, right? You asked. Okay, it's a great answer, right? So, number 5. How many possible combinations? So if it's a combination, right? We've got 3 colors from 7. So we're going to go 7, C3. Okay? It's a combination. 7, C3. Got it? Okay, now, where's our formula? Our formula is going to be 7 factorial over 7 minus 3 factorial times 3 factorial. Okay, that's my formula, right? That's my formula. Now, that's the same thing as 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, which is 4 times 3 times 2 times 1 times 3 times 2 times 1, okay? 7 factorial. 7, 6, 5, 4, 3, 2, 1. Okay?
Don't the 4, 2, 4,
Yeah.
3, 2, 1 cancel?
Yep, you're ahead of me. I like that. Good man. So I've got 7 factorial, 7, 6, 5, 4, 3, 2, 1 over 4 factorial, 4, 3, 2, 1. 3 factorial is 3, 2, 1. And where did I get this formula from? It's the NPR, NCR, which is n factorial over n minus r factorial times r factorial, okay? And that's the formula I used, and it's on the previous page, right? Now, Ben's right. Let's make this easy, right? So if I cancel all of these with all of these, right? And why not cancel this 6 right here with this 6, right? You with me? Let's cancel.
Cancel all those with the 7.
Well, I'm going to cancel this with my 6, and there's my answer, 35. Oh, wait, and, guess what? 35 is right here on Pascal's triangle. So Pascal's triangle, ready? What? Check it out. Pascal's triangle is combinations. I'm going to stop recording. Now, if it's a combination, if it's a combination, you don't have to do this work. You can use Pascal's triangle. Let me show you how. I'm going to go ahead and stop it.